how does the weather on the sun affect Earth weather? Space weather is basically weather within weather. And how's the weather on other planets? Our star, the sun, is a bubbling, boiling ball of fire. It constantly belches out great clouds of hot gas, and the gas is all charged up with electricity as well. And this travels at astonishing speeds. As we said before, we had a video updated just a few minutes ago on space weather. We have a solar flare coming at us at 1,000 times the speed of sound, over 750,000 miles an hour. This stuff travels at astonishing speeds, some of it right towards our Earth. And when the solar flare is Earth-facing, that means that the Earth's weather happens inside the sun's weather. So we're thankful that Earth's magnetic field and our atmosphere protect us from most of this blast of plasma coming from the sun. Otherwise, the sun's weather would be our weather, and that would be terrible, of course. But as we're still affected by the sun's atmosphere and its violent activities, we call this part of our weather space weather because it comes to us through the space from the sun. It's faster than a hurricane. Solar winds blow at about 600,000 to 2 million, that's 2 million miles an hour. The solar wind flows around obstacles such as planets and moons. But if a planet has a magnetic field, as Earth does, the charged particles flow around the magnetic field. The solar wind pushes on the magnetic field, flattening it on the side facing the sun, pushing it out into a long tail on the opposite side. And you can see Earth's magnetic lines of force. If you've ever used a compass to find which way is north, you've seen one effect of these lines of force. The compass needle lines up right alongside the line of force which come out of the Earth's magnetic field. South pole enters Earth's magnetic pole. Now where space weather is beautiful. The solar wind follows the magnetic lines of force, and some of the charged particles flow right down into Earth's atmosphere near the poles, the north or south poles. And when these charged particles hit Earth's atmosphere, they glow in beautiful shades of green and red, and we can notice the glow near the poles. I've seen them when I was about 12 years old, a winter night, Friday night. We were coming back from somebody's visit, late at night, and as I got out from the backseat of the car, I was sleeping because, it was a very cold, long drive. I looked above, and it was just a beautiful, sheer, colorful, waving curtain of rainbow colors. A very beautiful thing to see, very strange, because even though it was shivering above us, there was absolutely no sound. The white snow on the ground everywhere, sparkling, and all this shivering above us. The colors of a rainbow. It was just fantastically beautiful. I'll never forget it. Now we call these glowing colors the northern lights, and the southern lights the aurora borealis and aurora australis. They're beautiful curtains of light moving and swaying in the night sky. Usually you could see them only if you lived somewhere close to the North or South Pole. Well, I saw them when I was in Montreal, so it was not North Pole, but I guess it was because we had such a strong solar wind blowing that we had the aurora borealis and northern lights coming that far down. Now usually you can see them only if you live somewhere close North or South Pole, far from the equator. Sometimes you can see the auroras far from the North or South Poles. So when the sun gets extra restless, it has solar indigestion, sudden intense hiccups and burps called solar flares, the coronal mass ejection, CMEs. The effects of these types of space weather are not so pretty. As a matter of fact, they can be very bad for humans and their equipment. A solar flare happens when the sun suddenly burps out a blast of extra energy, and some of this energy is very high energy, called X-rays. The CMEs are even bigger burps. They're the biggest explosions in the solar system. When all these X-rays and charged particles reach our Earth, they can cause trouble. So where can we hide? Bad space weather can interrupt radio signals. It can damage satellites. Ships at sea may not be able to use navigation equipment that relies on satellites. Also, their two-way radios might not work and they can get lost or run aground in shallow water. Electrical systems that bring power to our homes and businesses can be knocked out by this bad space weather as well. And what about the astronauts living in the International Space Station or on a space shuttle mission? The space station and shuttles have radiation shields built into them, but the astronauts certainly would not go out spacewalking during bad space weather. The extra radiation could make them sick. Even airplane crew members can be affected if they fly often over the North Pole. More radiation from space weather events comes down into the atmosphere near the pole areas. And if only we had some warning. Just as we need early warnings about hurricanes, tornadoes, other bad weather, we have early warnings of bad space weather, helping keep damage to a minimum. This is due to the GOES, short for Geostationary Operational Environmental Satellites, GOES, solar X-ray imager, and other instruments that it has to measure the space environment, and these special telescopes can detect X-rays, which our eyes, of course, cannot see. Every minute they take a picture of the sun using X-rays. They give space weather forecasters information that helps them to warn others of solar events that could harm satellites and systems on the ground. The main job of the GOES is to watch what the weather is up to on Earth, and other types of satellites that monitor space weather is the POES, that's short for Polar Orbiting Operational Environmental Satellite. The POES keeps eye on Earth's climate, but also monitors the energy entering Earth's atmosphere by charged particles from the sun. Now, according to today's space weather, and I'll leave a link below for you for this, the solar wind is at speeds of 324.4 kilometers per second. That's a little bit less than 1 million miles per hour. The density is 1.4 protons per cubic centimeter. And we have X-ray solar flares, 6-hour maximum A9, November 13, 24-hour A9, November 13. The solar wind is coming. A hole in the sun's atmosphere is facing Earth and is spewing a stream of solar wind in our direction. Estimated time of arrival, November 16 and 17. There is a slight chance of a G1 class geomagnetic storm when the gaseous material reaches our Earth. And that G1 class geomagnetic storm, it seems the impacts will be on power systems. Weak power grid fluctuations can occur. On spacecraft operations, minor impact on satellite operations possible. And other systems, migratory animals are affected at higher levels. Aurora is commonly visible at higher altitudes, northern Michigan and Maine. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.